I'm actually surprised at the end of a day of a conference like this that there's anyone still here. Because I know if I was attending, I probably would not still be here myself. So thank you for pushing through and attending this presentation. So today we're going to be talking about security assessments and what to take into consideration these days when we're dealing with companies that have assets broadly distributed, not just centralized in a single data center. Now, if we think about a security assessment in general, up on the screen are kind of the basic categories that people try to cover when they're doing an assessment. Across the top, you've got manage, protect, detect, and respond. And across down the other side, you have the different areas of where you're trying to evaluate: the devices, applications, networks, data, and users. And when you overlay the different areas of where you try to gain visibility into, which I'm sure you guys can't see this at all, it's pretty small. But this covers things like looking at security policies, looking at security configurations on hosts and systems, doing vulnerability assessments, and so on and so forth. And when we think about doing a security assessment, it's usually kind of in this realm of doing a continuous assessment, where we're going to go off, do our analysis, get the data, bring it back. Based on the data we bring back and the analysis is performed, we're going to decide how we should respond to that, go off, come up with a laundry list of the things we should fix, then go off and repeat. But oftentimes, especially when you're dealing with a complex enterprise, you don't have the luxury of doing this cycle rapidly. Usually it may go over a 2 or 3 year period of time. The other thing to think about is when you're doing a traditional pen test, a customer or within your own organization, they'll tell you a number of hosts to take a look at. Based on those hosts, you will go off and look at their IP addresses. You'll try to determine the net blocks that are associated with those hosts. Then you go run off, do your vulnerability scan, your port scanning, to try to footprint what the network looks like for that company and try to find issues. And all of this works fine and dandy when you're dealing with an enterprise where everything is centrally managed and centrally located. But as many of you, I'm sure, are aware of, the landscape of IT has dramatically changed over the last 10 years. Assets are no longer centrally located in just one data center. There are a lot of cloud service providers of where systems are hosted. A lot of people are using software as a service type of applications that are hosted at other locations as well. And when you try to map this out and look at a typical large organization, things end up looking like this, where you kind of see this black dot over here. That's a data center location where some hosts are located for this company. And this is a Fortune 50 company. Everywhere there's a dot on this map is a place where one of their assets is hosted at a different location than their primary data center. And also, the other thing is with those data center locations, these are not data centers that they own. So that big yellow dot up in the upper right-hand corner, I believe that actually is Amazon AWS. The green one is Microsoft Azure. Down in that bottom right-hand corner is IBM. And you may look at that and go, well, that's a lot more complex than just trying to do a footprint on an organization with one data center. This looks like there's a lot more going on here. But if you start to factor in all the software as a service type of applications they have, it actually looks more like this. And again, this is an actual Fortune 50 enterprise. And this is just their highest risk third-party applications and where they're hosted. So if you're going to do a penetration test on a company like this, how are you going to approach it? your typical techniques of trying to discover a couple of hosts that they own, trying to discover the net blocks that they have, and doing a port scan and a vulnerability assessment, and then ultimately a pen test on some application. One, it's going to take you probably years to actually cover that whole scope, but two, how do you do it in a timely fashion? The other thing to think about in this new world where we have all this connectivity between different locations is you may go to great lengths in your organization to put policies and procedures and controls in place to restrict access to sensitive data. But when you go to ship it off to a third-party location, you can go put your encryption in place, you can use SSL to transport it somewhere, but how do you know what the location looks like of where you're shipping it off to? Is it something like this, which is, up actually where the church, the LDS church, stores their sensitive records here up in the mountains? Or is it ending up in a location like this in India? And yes, this is an actual business location in India. How do you know where it's going? And when you think about doing a traditional assessment, where I talked about the difficulties of trying to scale, doing a traditional pen test assessment in this complex environment. So what a lot of times happens with companies is they kind of reduce things down just to questionnaires, where you send off a questionnaire, you ask a bunch of questions about how they're handling security, and they respond back with policies and procedures, and they tell you the practices that they have. The problem is that, one, how do you know that information is truly what's being practiced? And if we chart this out, and on this dimension here down at the bottom where you look at cost, how much money would it cost to do an assessment? And on this other side, we're looking at how confident can we be in the outcome of that assessment. Your documentation review and questionnaire ends up being down here in the bottom left-hand corner, where yes, it is cheap, but you're not very confident, or you can't be very confident in what the reality is. As you move up the cost side, spend more money, you can go off and do an on-site visit and look to see how the facility looks. You could do your vulnerability assessment, you could do your full security enterprise assessment that we were talking about before, but those are very expensive. So the question is how can we move things into this other box where we can have high confidence in our assessment, but do something at a lower cost, something that scales, and something that will allow you to do more of a continuous assessment? Is there a way this can be done? And I'm here to tell you that using new techniques, it is possible to do something there. But you need to approach the problem in a different fashion than what's been done before. So this picture of this drone, I kind of view this, or just drones in general, the amount of information that you can obtain just by observing something these days is quite amazing. And if you think about it from a website perspective, when you go visit a website, what type of information is available to your computer behind the scenes that you don't even know about necessarily? And if you just go to Google's website and actually look at the code that comes back from their web server, this is just a very small snippet of what's in there. But there's a treasure trove of information that's in there that you can use to find more information about that system. And let's map that out. So if I just go visit a web server, and that's what that little circle is right there, just from visiting that web server and looking at the information that comes back, I can find out its IP address of where it went to. And from that IP address, I can find out where that system is hosted. I can go look that IP address up, doing a whois lookup. I can also determine if that IP address is dedicated to that system itself, or if it's shared by other websites. I can also look at threat intelligence data exists for that IP address. Also off the IP address, I can do geo-IP lookups on it. I can find out physically where that's at. What country is it in? Is that country a sanctioned country? What are the regulations in that country? In looking at a little more interrogation of the code that comes back, specifically the HTTP headers that come back, I can possibly identify the type of software that's running on that system. And based on that version of software that I can see in those headers, I can tell if it's patched or not. I can also look at configurations based on the types of pages that may be available on the website. If they're using JavaScript on the web page, I can actually look at the source code. I can see what libraries are being called in. I can look and see if those libraries have any vulnerabilities associated with them. From that host name, I can then go look up the domain that exists with that. I can then go look at the domain server, look at its configurations. I can see if domain hijacking protection's been enabled. With that web server, I can see if SSL is in place. I can look at the configurations of what ciphers it supports, what version of SSL is enabled. And going back to the domain registration again, I can find out the email server by just doing a simple MX lookup on the domain. And on that email system, I can then interrogate if encryption is enabled. I can also look at what type of authentication is in place. So all that information, all that data is available to be analyzed when you simply go visit a website. The question is can something be built that can handle all that data and process all that information? And the answer is yes. Now, if we take that, put it into something that's doing a web crawler, and then analyze that data as it's crawling through different sites that are connected to that web server, you can start to see some pretty interesting pictures of a company and what its footprint looks like. In these next series of slides are going to be two examples of where we've applied this technique to 2 Fortune 100 companies. And this first one is a data processing company. And all this information we're going to show in these next couple of slides. This is all situations where we had no inside visibility into the company. All that was provided to us was just a host name and a name of a company. No hacking was done, no port scanning was done, no vulnerability scanning, no pen testing. From just simply connecting to one website, we're able to discover 265 other web servers that they had on the internet. Now, these could be situations where they had connectivity between them. Could also be situations where we did lookups on searches on the domain to find what other hosts these companies may have on the internet. From those web servers, we discovered that they were located at 28 different hosting providers. So again, not everything was on their own network, and that big black box you see, that was the company's own network. And the size of these words depends on how many hosts are at those locations. So you could see, at United Hosting and EasyLink Services Corporation were some places where they had more hosts than others. We were able to discover that those websites were hosted at 7 different countries. They had 6 different email providers. This is all the software we were able to discover by just interacting with those websites. And again, and not in a vicious fashion, just by doing simple web crawling. But based on that information of these software, we could figure out in most cases what the versions of software was. So in looking at just web server patching, we discovered that 8% of their servers that were on the internet were running end-of-life software. Some of it as old as IIS-4, which is really old. It may be older than some of the people in the audience here. 12% of the systems, the application servers we saw, were running end-of-life software, old PHP, old Fusion Passenger. 60% of their content management systems were running end-of-life software. And again, these aren't versions of software where there's a patch that's available to use. These are versions of software where the vendor is no longer supporting it. End of life. So overall, 15% of their systems running end-of-life software. Now imagine a situation if I did my questionnaire assessment and I went to this company and said, hey, what are your practices and policies around software patching? And they tell me everything is patched within 30 days if it's a critical vulnerability, and within 90 days if it's a lower risk vulnerability. Doing something like this, I actually have objective evidence to call them out on it. In looking at their web encryption, 12% of those sites that we discovered were running with expired certificates. 32% had invalid certificate subjects. 36% were running on old versions of SSL, which had known exploits out there for them. 36%. 45% of their DNS configurations were missing just basic domain hijacking protection. We saw similar things with their email security. 44% had no encryption in place. 97% weren't using any SPF or DKIM, any of the new authentication techniques that are out there. It's kind of interesting of what can be observed about a company without doing traditional pen testing techniques. So let's look at another company. This is an insurance company. Again, just using the same techniques that we talked about before. This organization, we discovered 347 web servers. Again, just starting with just one website and one company name. Those sites were hosted at 42 different locations, 18 different countries, 33 different email providers. Lots of software was discovered. And again, from a patching perspective, 20% of the systems that we discovered were running end-of-life software with this company. And this is a Fortune 100 company, so this isn't some small mom and pop shop organization that's out there where you'd expect security to be worse. This is a company where you'd expect them to have their act together with security. Similar situation was discovered with their web encryption. Old versions of SSL, old certificates that expired, non-properly configured DNS, not properly configured email. So again, going back to this question, how do we get here in this upper box? What could we take advantage of now to find this type of information out about systems? It's kind of beyond the scope of what I think people traditionally think about doing a pen test with a company, where you find that one website, you do some Googling about where their data center is located, what are their net block ranges, what can be done to discover everything that they have and the relationships they have with third parties. Well, I propose that when you're doing an assessment, you really need to think about things from this angle. Your footprinting methodologies need to account for any of the as-a-service type of things, whether it's infrastructure, software, or whatnot. You need to think about third-party hosting providers, the cloud providers. You need to think about if that company has IT that's outsourced. What are the third and fourth party relationships to find all the interconnectivity between systems and companies that exist these days? And then on the back end, instead of just focusing on running a vulnerability scanner and running a vulnerability scanner, come up with a different way to deal with just being able to interact with systems in general. So do web crawling. Log the data that's coming back with your web crawl. Mine public data sets, WHOIS databases, domain registration databases. Get your hands on open source, third-party data sets with IP reputation, And then do analytics, data analytics on top of it. Using those techniques, you can then do passive vulnerability assessment. You know, again, not as good as doing a regular vulnerability scan, but to do a vulnerability scan, a traditional one, you need to have permission from someone to do that. Using these techniques, you don't have to have permission to do that. And again, you know, ultimately the goal with this is when I'm doing an assessment, can I determine if I'm dealing with a company or organization like this, where there's great controls in place, or am I dealing with something like this? So that is it. Thank you for your time and for sticking around. Does anyone have any questions? We've got a couple minutes left here. Yes.
So when you're dealing with secure data sets that you share with third parties, for instance, at Davis County School District, we have vendors who run software for, we send them our teachers and our login information for students, et cetera, so forth. What's the recommended method of dealing with that? In other words, that if I send them the same username and password that they're using in the school district to this third-party vendor who knows where their data sets lie, you know, it's convenient for the students that their username and password is all the same for everything, but yet at the same time, kind of an inherent risk that we're kind of talking about right now is.
That's right. And I think what you need to think about for your organization that you're talking about is, you know, a lot of times when you come in and the auditors do an assessment of your location. Let me go back to one of these first slides here. You know, they're kind of looking at things this way of, well, hey, we're going to do an assessment of Davis County School District. We want to see what your policies and procedures are. We want to see how you're protecting data within your organization. If you have data that's outsourced and somewhere else, you need to apply those same assessment techniques to everywhere where your data is located. I mean, that's where we really need to go these days. It's not a situation where we have centralized data centers and you can do an assessment just in one spot or one location. You need to think about it holistically. And part of the challenge is because of the cost of doing these assessments at many locations, it ends up being pretty expensive. We're proposing that by using different techniques, you can get a higher level of assurance and identify if issues exist at those third-party locations where you're sending your data off. You can still get visibility into how secure it is by just using new techniques. While the old audit procedures are great, they just don't scale when you're dealing with the modern organization. And again, this picture right here, this is only this company has deemed as their highest risk vendors of where they're sharing and sending their data. If I was to include all of the vendors, all the places that the data is actually located, it just looks like a big ball of yarn. There are so many places where that data is being pushed off to you. But great question. Yeah. Good question. This is kind of a data science question. But with the application that my company has built, as we're interacting with websites, we're looking at the characteristics of those websites. Does that application have authentication in place? If it has authentication in place, it probably implies it has sensitive data that's trying to restrict access to. As we're interacting with those websites, we're grabbing all the form field data so we can see what kind of information they're requesting from people. Are they looking for a social security number, a user ID, password, date of birth type of stuff? Gathering those types of attributes back, you can use that to classify the website. Is this just a blog? Is it a shopping site? Is it a banking site? And you can put sites into different categories doing that. All right. Well, I don't see any more hands raised up. Thank you again for your time, and enjoy the rest of your day.